Okay, welcome everyone to another workshop here. Today's topic is product design. We're going to go through a few different concepts here. I mean, as usual, we'll start with some fundamentals and the objectives, and then we're going to get straight into the details of how to get started on your own product design and what you should be thinking about. And the reason that I think this is an important topic, especially related to careers, is because every company that you're going to go work for has come up with either a product or a service that they are offering to the market. And the better that you understand how those products were designed or created, the better an employee you're going to be, the better a designer or an engineer or a developer or whatever kind of role you're looking for to be taking on, the better employee you're going to be in that role. So as we usually like to start with a question, I will do the same thing here. So for those of you that are here, please feel free to type into the chat. The question is, simply put, what is a product? So if you were to give me a definition of what a product is in very simple terms, what would that be? I'll give you a couple seconds here to type it into the chat, or if you'd rather just jump on your mic, go for it. A material, good, or service that you're trying to sell? Sure. So to give you a little bit of a hint here, so basically, when we think about what a product is, it's typically a solution to a problem, right? Most of the time when people think of how to create a product, or if you're an entrepreneur or you're trying to create an idea, you're usually trying to solve some kind of problem. And that is the fundamental point of how to understand what a product truly is, right? And if you look at any product in the market or even a service, they're usually providing solutions to problems. And the more that you can think about it in those terms, the easier it's going to be for you to understand the entire concept of product design. So I like to simplify things, and that's where I think this is a very simple answer. I mean, obviously, Bernard's point there about it being a good or service that you're trying to sell, yes, that does fall into being a solution to a problem, which is why it's technically correct. But if we were to simplify it down, I think calling it solutions and problems is going to be an easy way for you to understand and apply it to the analysis that we're going to take on the next few slides. So I have an example here of a potential problem, and I want us to do a little bit of an analysis here. So again, looking for some audience participation. We're going to try and break down this problem and the product / solution that is there to determine whether we believe this is a good problem statement and whether there's something we can add or subtract, or if this is good and we should start then designing our product based on it. So that being said, what do you guys think about these statements? Do you think that the problem statement is good? Do you think that the product statement is good? What would be your critique or analysis on any one of these things? And you can type it into the chat, or if it's easier for you, it might be easier just to jump on your mic and give us your opinion.
I think the problem statement is good. It's not too broad, but I don't think it's too specific either. Like, I think there might be multiple solutions to it. So I think it's pretty good.
Okay. And what would you say about the product statements or paragraph there?
Yeah, I think that one is good too. It's detailed. It's kind of like something you'd say if you're trying to sell it. So yeah, it goes into depth with the features and everything.
I think both are actually pretty well done. They're just both different for different occasions. Let's say the problem statement is maybe when like summarizing really quickly, maybe like a subtitle or something, like just to be really brief and just show all of the main idea of the product. And then the product statement is basically like going into depth, like they said, like basically summarizing but adding more detail.
Yeah, so some good points from both of you. So I'm going to take you to the next slide here, and you can see what my critique would be. So I simplified that problem statement. I know, Frank, you had mentioned that it was a fairly concise statement. I decided to make that problem statement even more concise. So I turned that problem into a very specific term, which arguably isn't necessarily a real term in the industry, but this is just me making it into a very short terminology or set of terms that can describe what the problem is. And in my mind here, the problem is accessing power in a remote situation. So remote power access, right? Now, Ananya has made a good point there that there is some detail here and that there is a description that is going to be providing the information and that is going to be able to describe it from like a sales perspective. And I think that's exactly the point that I would be trying to make as well, is that when you're writing out these kinds of problem statements and product statements, you have to think about your audience. So what Ananya alluded to is that the product statements here would probably be relevant or useful to a marketing or a sales audience. Would I say that this product statement is a technical specification that I could build a device or product from? I would argue probably not. And there's a reason for that, and we'll kind of get into that in a few minutes. But the main point here is that you can be trying to write your statements for different audiences. And to be able to write a problem or a product definition, you have to understand who your audience is, because I should not be writing the same statements for a technical engineer who's designing this product as I should be for a CEO or a salesperson that needs to pitch this to a potential client or a potential manufacturer, right? So those are two different things. And as I've shown you here, I've summarized them in different ways. So even the product statement itself, some of those areas or some of those points I've highlighted in red. And the reason that I've highlighted those ones in red are because they may or may not be necessary to help describe the product. So we want to try and be critical about this. And we're going to go through another couple examples here of how to be critical about statements, because that is one of the challenging things that we're faced with in our world, even just on a regular basis, when politicians say things or our professors say things or our classmates say things. Those statements are coming from different places with different amounts of information behind them, different agendas or a different purpose behind them. So we have to try and be critical about the words that are being used. And especially in a problem or a product statement, we don't want to add any extra fluff unless that is the purpose and we are trying to sell something to our customers and we want to add certain words. But for example, we're going to go through the green statement that I have at the bottom there of what the product is. And there's a word that I would pick up on, or two words that I'm going to pick up on just right now ahead of looking at that slide, but reliable enough. Technically, that could be a useful term, but in my opinion, that definition would be very critical for us to understand, right? What would we consider to be reliable enough? That is probably debatable. Maybe within the detailed specifications that can be defined, but in terms of what do we see here on the screen, it's not necessarily telling us what that is, right? So for a non-technical customer, that might be fine, right? That gives them the general gist of what this product's supposed to be, what it's supposed to cover, what its purpose is, but it doesn't necessarily tell us what we're going to be able to use it for, right? So jumping a little bit ahead here, but we're going to go into another example before we jump back to this one. So this is a problem statement that a student had given to me a while back, and I found it very interesting, just as a single sentence. So what I'd like us to do is go through this sentence as well, and let's try and pick it apart, right? And not pick it apart in a bad way. I just mean pick it apart in terms of defining any of the terms that we think might be questionable or that we think need a definition, right? So again, feel free to jump on your mic and let us know, but try and pick a term and try and give us a definition, or better yet, try and give us a critique of this statement to show that you're trying to analyze this and that there might be a potential hole in the statement itself.
Yeah. Yeah, I think the problem statement should just mention what the problem is, not whose fault the problem is.
Okay,
It should be just, yeah, a clear and concise message of what the problem is.
sure. Yeah, I think that makes sense. As a statement, it's interesting because we can actually break that down, and we could give a definition for fault and maybe it can still fit in. But as an actual problem, I agree with you. It's not necessarily required to say whose fault it is, right? Yeah, good. Any other points or definitions or terms that we want to try and clarify?
I think in general, it could have a couple more constraints. I think it might be too broad of a problem statement.
Yeah, for sure. I think definitely they're alluding to a certain point, and they're not necessarily defining the word. So for example, I would pick on the word our, right? Climate change is not our fault, but it will be our job to fix it. My first question is, who is our, right? And I think there could be multiple answers for that. Obviously, I know who said the statement to me, so I technically know who our is. But if you didn't know who that was, that would be something to question, right? Because somebody who might be 20 years old that's saying the statement compared to someone who's 80 years old who's saying that statement is going to be implying different things, right? So here's just some definitions that I've thrown up here, and these are just straight from Google, but these are, again, just to help us to understand how to define a statement, right? Or how to break it down. And the idea here is that even in such a simple sentence that's only like 10 words long, we can actually break it down into a much larger, not more concise, but more expanded, but better defined statement, right? And it's important for us to be critical about this because as we're defining products, we don't want to have any vague statements or definitions that we don't know how to define, because especially when we start defining or describing or designing something technical, we don't want to have ambiguity, right? Ambiguity is going to make it very difficult for us to design something, because at the end of the day, if we can quantify something or at least qualitatively describe it with a set definition, it's going to be a lot easier for us to design, right? So using that as our example here, you can see that we can actually do the same thing with the product that we had described earlier, right? Again, these definitions are just coming straight off of Google. I did not make them up to help you determine what that is, but at the end of the day, the point is we're trying to define each word or each set of terms in the statement, because like I keyed on earlier, it seemed like it was a decent enough statement, but when we really dig into it, there's terms like durable or reliable enough. When we look at the definitions of that, so if we take durable, for example, right? Able to withstand wear, pressure, or damage. My first question is, well, how much wear, pressure, or damage, right? Same thing with reliable or reliable enough, right? Reliable enough implies that there is some specific standard or metric that should be used to define that level of reliability. And as Frank's mentioning there in the chat, reliable enough is not really required, right? That being said, we do still need to define what reliable means, because we need to set some kind of standard to it, right? For example, when you're designing products, I've worked with companies that have designed products for consumers, for industrial, and for aerospace or military grade. Each of those would have a different definition of what reliable is, right? Or what durable is. And that's where we end up eventually translating that into technical specifications, which is basically the next step of where we want to try and go. Because at the end of the day, again, if we're trying to design something, we need to have limitations or restrictions or things that are easily quantifiable, because otherwise it's going to be very difficult to design our product that is quote unquote reliable or quote unquote durable, right? So we have to be careful when we're creating these statements, because at first glance, they might seem like they're a good statement, but they might be leaving out some technicalities to it, which is going to, again, make it very difficult for us to design. We're going to go through another example in a second here, but the first thing I want to show you guys is this connection or chain of statements, or I guess terms, that end up being what we call product requirements. So when you're looking at designing a product, most of the time you'll come up with a document, or you'll come up with some kind of specification that will detail or describe that product, right? So we just looked through a couple of examples of probably the first couple sections of the product definition of a product requirements document, right? So typically you're going to describe the problem space. You're then going to describe the actual product or solution. And within that, there are each of these different levels. So I'm going to go through them very quickly, and then we'll show you a quick example of what that would look like if we were to define an actual product, right? So obviously at the highest level is the actual product or solution that we're working on. Below that is a set of features. So no doubt you've bought products before, and when you're buying or looking at different products, you're probably going to be able to compare the set of features that they have, right? We're talking about smartphones. There's different features that each smartphone will have coming from each different manufacturer or company that's designing or building them. And that's something that you want to be able to consider to be able to say, hey, I'd like to buy an iPhone as opposed to a Samsung, right? And sometimes those features will be overlapping, but sometimes they won't. So it's important for you to understand that as you're designing a product, first step is to decide what kind of features do we want to have that this product is going to incorporate, right? The next step there, and it's kind of a parallel step that goes with features, is defining the use cases. So what I mean by use cases, and for those of you going into design-focused technology programs, use cases are very important because you want to be able to understand how will those features be used, right? That's as simple as I can put it. And that's really going to help you to understand what the next few steps are, right? So with a certain feature, so for example, you have a camera might be your feature on your phone, right? Now the use case is, well, you can use that camera to take a picture, or you could use that camera to take a video, right? Those are two different use cases for the same feature, right? Once we go to the next level, that basically means that we're going to have to understand, okay, well, what does that feature or use case require? Or what is going to be necessary from a detailed perspective to be able to be incorporated in our requirements document so that we know what to design for, right? So if we were to buy a camera that we were integrating into our product or our smartphone, we would have to make sure that camera was capable of processing not just images, but also videos, right? So now we're starting to get more into the details of what does the actual component or the feature require for us to be able to say that it's meeting our use case or meeting our product requirements, right? And the next step, or I guess the final step after that, is once you've defined your requirements, you're going to want to specify or find or quantify a technical specification, right? So maybe you want to look at the number of megapixels that camera has, right? Or the frame rate, or the physical size of it to be able to fit into your phone, or the pixel density, or whatever, right? So those are just kind of the natural steps that you want to get to, but all of these pieces are what are going to fit into your product requirements, which is what you're going to need to be able to define or design a product effectively. So looking at the following example here, we're going to go through from problem definition all the way up to technical requirements to help you, again, better understand how we would actually put this into a document, right? So let's go back to our climate change concept that we were talking about earlier. The problem that we're deciding to work on right now is the Earth climate is becoming uninhabitable faster than expected. Okay, that's fine. That may or may not be a good statement to start from, but for the purposes of this example, it's probably good enough. I don't think there's too many words or terms that are in there that are ambiguous or difficult to understand. So arguably, it's a reasonable enough starting point for us for a problem definition standpoint. Going to the product definition, basically, this is, again, a very simple way of saying, okay, well, we have a problem, so what is our solution going to be? And in this example, we're saying that we're going to build or design a machine that is going to slow down climate change. Now, logically, if we look at the problem definition and then we go to the solution, we can see that the solution does attack the problem, right? So how does it actually do that? Well, that's another whole story, and that would be digging back into the requirements to be able to understand how exactly it does that. We'd have to start building use cases and features, but obviously just for the purpose of this example, just understanding what that solution statement is a good enough point for us for now. So without going into the entire solution or how this product would actually be working, we can at least agree that there's probably going to be some use for a measurement of temperature, right? So one of the features for sure, basically what capability does this product have, it's going to require some kind of temperature monitor. How will that feature be used, and therefore as a use case? Well, temperature is going to have to be measured at various locations on the Earth, let's say, right? Now, what we want to do from there is we want to be able to describe the requirements, or basically what does a product require to be able to support that feature or use case, right? Now, a lot of times this gets confused with the feature section, but essentially this is a more detailed version of the features and or use cases. So that's the statement that's there is, well, we should be capable of measuring temperatures between the hottest and the coldest regions on the Earth, right? Which basically we can translate into a technical specification in essentially a quantifiable way, which allows us to say, well, we probably need a temperature monitor that has a temperature range from, let's say, -40 to +85, and measurement accuracy of ±1%, right? That's not to say that those are the only measurement requirements or technical specifications that we would need for a temperature monitor, but these are just examples to help you understand how we would actually build this out, right? And so similarly with our smartphone example from earlier, we're going to require that we define all of the features and all of the use cases so that we can then determine what is going to be required or what kind of specifications we need so that we can eventually get to the next couple stages, which is the actual design, right? I'm going to show you a few examples here of system architectures, and there's going to be a reason that I'm going to be showing you these. So hopefully you're paying attention right now. I'm not going to ask you to memorize or even be able to explain or understand any of the terms that are in here, but I want you to take a look at this and really try and absorb what is going on here, right? So if I was to break this down, I would probably maybe start at the top and I would start reading through it. And obviously, as you can tell, it is quite complex, right? This is basically a technology stack or a technology example that is showing you all the various layers of what's going on within, let's say, a smartphone for the voice over IP implementation. So again, what does that really mean? That basically just means that from the hardware level all the way up to the software level, there are all these different pieces set up as part of our system. So each one needs to be designed or defined or integrated as part of the system. And obviously you can tell it's going to be quite complex, right? So we can look at a few other examples here. This is an example of social networking, basically the transfer of data for a transit app. And this one is just an image of the Tesla, I think it's Model 3 engine or compartment from the mechanical perspective, right? So after seeing these examples, and this is a question for you guys, do you think it's possible to be able to describe or explain each of these complex systems in 10 seconds or less? Frank says no. Yeah, fair enough, Frank. That's definitely the first thought, which I expect everybody to have. So I'm going to give you a way to do it. So if we go back to this section here, if we were looking at this, could we describe what this is in 1 or 2 words? Or maybe this one's an easier one. Could we describe this based on what I'd said or what I told you about it earlier? Bingo, Tesla engine, right? And that's exactly where I'm going with this, right? Is we can describe any one of these systems or architectures as a black box. I mean, obviously in the image it's blue, but arguably that's the same function, right? Every system that you can think of will be able to be described as an set of inputs with a black box and a set of outputs, right? Literally every system, right? So the reason I wanted to explain this to you is because this is where you should be starting from when you're looking at designing any system. Start at the highest level and build out your blocks, right? So for example, if I was to tell you how to design a smartphone system, me personally, I've worked in power electronics at multiple smartphone companies. I may know the details of how that works or how the power system is architected or designed, but that's one very specific subsystem, right? There are 10, 15, maybe 20 subsystems within a smartphone product. But at the end of the day, we still describe it as a smartphone, right? Which is the highest level block. And the point that I'm trying to drive across here is that when we're thinking about complex systems, it's always easier to start with the simplest, highest level, right? Because at the end of the day, what we can do is we can break down this X into smaller subsystems, right? So if X was a smartphone, okay, maybe A is the power system and B is the display, right? But at the end of the day, we're still just showing the same thing, right? We're still just showing that A and B as subsystems are part of this larger system X, right? Which is exactly the same thing as what we were showing you earlier with all of those different complex system architectures, right? And the reason, again, like I want to stay on this point for a few seconds here is because it's important for you to understand that just because something is complicated doesn't mean that we have to describe it that way, right? And this is the difference between technical people with a technical background only and those that end up getting into the kind of the business side or end up being able to explain things to customers or become customer facing. A lot of times, technical people want to describe systems like this. But depending on who your audience is, again, they may not understand what you're talking about. So even as you're describing things to people, you might want to think about using this higher level design focused example, right? Or this block diagram. And again, the whole point here is just to help you to understand that, yes, we can get complicated, but technically you can draw out any system architecture in terms of a block diagram right now with as little or as much understanding as you have already about any system, right? And that's the whole point, is that as you're designing systems, you want to start at the top and then work your way down. A lot of times people get focused on trying to dig in, okay, well, I need to know this. And then once I know that, then I can go into the next level. And then what about this? And you just keep going deeper and deeper. But that isn't always how you need to design something, right? Even with very complex systems, especially from a prototyping perspective, which I'll kind of talk about in a few minutes, from a prototyping perspective, a lot of times we don't want to have to design anything from scratch, right? A lot of times we'll buy something off the shelf that is a combination of complex things, but we're going to treat it as a black box and we might just talk to the input or talk to the output, and that's as much as we're going to do, right? When we're designing smartphones from scratch, or when we're working in, and I worked in some of the advanced development or future products departments, we would take off-the-shelf components and we would just connect them to other off-the-shelf components. So for example, we would have a processor board, which we would then connect to a power board, which we would then connect to a display board and Wi-Fi board and so on. And the whole point is because we don't want to have to design or build everything from scratch all the time, right? A lot of times it's more effective to be able to just use these higher level blocks, or even let's say the Tesla engine. If we just had that, maybe we could just plug it into whatever other components we needed to get it to prove out whatever concept we're going to do, right? So again, the point here is to be able to understand that every complex system can be described and designed from a very simplistic point of view. And that's not to say that it isn't complicated, but the whole point is that you want to be able to start there, because sometimes you need to get to the deeper level, but sometimes you don't. And if you try to start at the complex system like we showed here, and you have to go through all of these blocks to be able to understand what this system does, that's probably going to take you a lot of time. And at the end of the day, we probably don't have a lot of time to be able to go through and decide or understand everything, which is going to be counterintuitive for you guys, or for a lot of you, because a lot of you feel comfortable with the more that you know. But as you enter the workforce, you're going to start realizing that it's going to be very impractical for you to try and know everything. And the best option for you is to understand as much as you can, or as much as you need to be able to move on. And a lot of times what you're going to end up with is this. A couple more points here, but we've basically just gone through the design planning phase. I'm not going to go through a ton of detail on the design implementation phase, because I think it's more important for you guys to understand the planning piece of it. Because at the end of the day, this is the kind of thing that you're not going to be able to see, or the chances are you're not going to see a lot of when you get your first couple jobs. A lot of times you're going to be plugged in at the verification planning or verification testing level, but understanding the design itself, from a definition up to the system architecture, down to component selection and so on, understanding all those pieces are actually very important, because if you can understand those, it's actually going to help you with verification, which again, like I said, is probably going to be a lot of your jobs. I mean, obviously I'm speaking to more of the technical side of product design, which is not necessarily the case. I mean, if you're in marketing or in the business side, obviously still be working on products too. But at the end of the day, the point is, if you understand how a product is designed or how it's defined and architected in the first place, it's going to help you to do your role of a verification engineer or a designer or developer a lot easier, right? So to go through each of these points here pretty quickly, component selection is basically the next step that happens after you design your system architecture. A lot of times these things will happen in parallel. So especially speaking from the hardware side, we would have to define our product in terms of the features, requirements, and use cases and all that. And then we would, as we're jumping into the system architecture, we would actually have to look at potential components we were trying to select at the same time, right? So we weren't able to just design this theoretical system without understanding what potential real components we could actually use, right? So a lot of that stuff kind of happens in parallel. But once you get past the component selection, then you can get into the detailed system design, right? That obviously can happen on the software side as well, where you think of the higher level blocks or classes. And then as you dig in, you start defining or designing your functions or your or variables, or basically the flow of data or information or whatever it is that your product is actually doing, right? So those are in terms of design. What happens after that is typically verification planning. So even within the system architecture or design phase, you want to think about designing from a verification standpoint, right? A lot of times I've seen products or even boards that have been designed from a hardware perspective that were only focused on the design itself, which ended up being very difficult to test, right? They didn't think about how they were going to test certain features, which is definitely part of the design. So that's something you want to be thinking about as well. And then obviously once you've planned that out and it's made its way into the design, then you're going to be running verification or validation tests. And then once you get through that, you're going to review the results, you're going to analyze them, you're going to understand what worked and what didn't, and you're going to hit the next cycle or revision, which is basically the design review or iteration stage, right? Most of the time, designs are not created perfectly, and that's essentially what my last couple slides here are going to be about. So if you haven't seen this before, you will see this in the future. This is basically the feedback loop, right? So there's a couple questions that I want you guys to think about here, and we're going to go through it. But essentially, if we look at this diagram, what's happening is we're starting at the input, we are performing an action, we are looking at the result, and then we are getting some feedback and feeding it back into the next revision, right? So this is the feedback loop, or essentially the iteration process, right? So again, if we think about the product design that I was just describing, the input or the action will be to design the product or build the product. Then we do our test verification or validation, and we collect our results, at which point we feed those results back into our design to go through another cycle to be able to improve or perfect the product, or help us to reach or meet those requirements that may or may not have been satisfied. So with that being said, what do you guys think is the most important element of this process? And that's in terms of looking at this diagram. Which of these 4 blocks do you think is the most important?
I guess I would say feedback. Oh yeah, like Anaya said, like feedback, because you can always like try and make different products. You can always like continue to try different things, and then when you receive feedback, you can like improve and make better results and make a more efficient plan. Because the first time might not always go as efficiently as you hope it will, or as effectively as you hope it will. So if you gain more feedback, more suggestions from multiple sources, like even if they're not, say, professional or experienced, if you get more feedback from multiple people or like multiple sources of information, then you can help improve your product like exponentially, to the point where the result will improve like to the point where it will become successful. So I think feedback is probably the most important part of the process.
Yeah, exactly. Absolutely. Feedback is definitely the most important. I mean, I think JP put input as being important as well. I definitely agree. I mean, all the pieces are important, but if I was to pick the most important one, it's definitely the feedback, right? So that being said, why is that important, or what is the implication of feedback being part of this process? I'll give you guys a second to think about that one. But essentially, the fact that there's feedback included implies something about our design or our design process. So what do you guys think that would be?
Essentially that it's not like one and done, that the fact that you're seeking out feedback means that you're pretty sure that you're not going to get it right or perfectly the first time, and it's important to keep on iterating.
Exactly. Yep. You nailed it. So that is essentially the concept of a design, right? Which is if it was a perfect, if our design was perfect, we wouldn't need the feedback, right? And therefore this model wouldn't really be required. But as we know, and as you start getting into designs, you'll realize nothing is ever designed perfectly, right? And the reason I want to harp on this point is because this is counterintuitive based on everything that we've been taught in school, right? And not in terms of necessarily whether we've been told, okay, we need to be perfect, but everything we do, we need to compete against other people, right? So we're trying to get as best of a mark or a grade as we possibly can, which also makes sense in that scenario, but it's also very impractical when we think about it relative to product design, right? Because we know that if we're thinking about it from an efficiency perspective, it's actually faster for us to design something imperfectly in a month, start testing it, get some feedback, and then fix those mistakes or those errors in the next month, right? As opposed to working on it for 3, 4, maybe 6 months, trying to get everything perfect from the start. We're actually spending more time, right? And I'm sure you guys probably recognize this from studying. If you're trying to get perfect or you're trying to get a really high mark, you end up spending a lot of time studying, or maybe you haven't done that yet. But if you start getting into university, you'll start to realize that that's what might be required. But at the end of the day, that's counterintuitively not the process that we follow when we get into the industry, right? We're more focused on saving us time, right? Perfection is a very difficult goal to achieve. And most of the time, I mean, I'm sure you've noticed even some of the products that you might buy, they're not going to be perfect, right? Your phone might have bugs. Your computer might crash from time to time. They designed these with some really smart people that figured out how to create these complicated system architectures, which solve a lot of problems or give us a lot of features. But at the end of the day, they knew that they designed it imperfectly because that was an efficiency point, right? They needed to do that because otherwise, if they were designing it to be perfect, they'd never sell it and they would never get out the door, right? So the point here that I'm trying to drive home is that we don't want to be focused on trying to do something perfect, which is going to be very counterintuitive to you. I've worked with a lot of students, and especially in the first couple jobs that you have, your natural inclination is going to be to try and do it perfectly, right? You don't want to mess up. You want to show them that you can do something well. But at the end of the day, you have to realize that that's not really part of the process, right? We don't want to be trying to focus so much time and effort on being perfect that we miss the feedback, we miss the point, we miss the entire process of what it takes to design that product that we might be working on in the first place, right? So thanks again, everybody, for joining and participating. I hope you guys learned a lot. And I look forward to doing the next one with you soon.